Hello everyone. Friends, today also we are going to discuss regarding the concrete. In last lecture also we have discussed regarding the concrete and the various the operations which are associated with the concrete. Today we are especially discussing regarding the plain cement concrete and the various grades of concrete. Now before that, before proceeding further, let's have the glance on the content of the unit 3. So in this we are going to study regarding the plain cement concrete properties, grades and their uses. Also we are going to study regarding the stone masonry, in that random rubble, coarse rubble and ashlar masonry. Then also we are going to study regarding the brickwork, brick bonds, English, Flemish, principles observed during the construction. Now, concrete, a hard mass obtained by mixing of cement, fine and coarse aggregates with water is called concrete. Sand is used as a fine aggregates, whereas gravels, crushed stones, etc. are used as coarse aggregates. The cement acts as a binding material which forms a paste with water on hardening the aggregates together to form a solid mass. What are the ingredients of concrete that we have discussed again earlier and will discuss now as well? The ingredients of concrete are as under, that is cement, aggregates, water, admixtures. Now, what are the functions of these ingredients in concrete? The function of each ingredient of concrete is discussed here. Cement, it is the most important ingredient of concrete. Its function is to bind the aggregates both fine and coarse together. Water, its main function is to lubricate the aggregates and cause chemical action with cement called hydration. Water used in concrete should be pure without any impurities. Fine aggregates, the aggregates which pass through the IS sieve number 4.75 are called fine aggregates. Fine aggregates are used to make the concrete dense by filling the holes of coarse aggregates. That should be a whites of coarse aggregates, and also help to reduce the shrinkage of cement on hardening the concrete strong and weather resistance. So again here also the fourth component, you can see the admixture is also there. So that depends upon the for what purpose you are going to use the concrete. And also the aggregates which are retained on the these 4.75 mm, those are called as the coarse aggregates. Now let's discuss further the properties of concrete. The main constituents of are cement, fine aggregates and coarse aggregates. The properties of a particular concrete are influenced by proportion, by weight of these constituents. The concretes are usually designated as 1 to 4, that is 1 is to 2 is to 4, 136, 148, etc. A 1 is to 2 is to 4 concrete signifies that it contains cement, sand and broken stones in the ratio of 1 is to 2 is to 4. Sand is usually termed as a fine aggregates, whereas broken stones are known as coarse aggregates. The properties of these constituents also affect the properties of the resulting concrete in various ways. Hence, to study the properties of concrete, it is essential to study various constituents and their properties. Now, let's discuss the properties of concrete in more detailed way. First is the water. The different proportion of water in concrete mix adversely affects the property of concrete. The ultimate strength of a concrete is less if amount of water added is more and vice versa. The ratio of water and cement in a concrete mix is therefore a very important factor for deciding the strength of a concrete. The ratio of water and cement by weight in a concrete mix is known as water cement ratio. Second, aggregates. There are two types of aggregates, that is coarse aggregates and fine aggregates. Though aggregates are inert chemically, their size and shape also affect the properties of the resulting concrete. Compaction, the process of removing air from the voids, empty spaces between the aggregates of a concrete mix, is known as compaction. Compaction of concrete may be different methods. The method adopted for compaction also changes the properties of the resulting concrete mix. The concrete, when freshly mixed, remains in plastic state, and after hardening it becomes in solid state. The properties of concrete in both states are discussed here. Properties of concrete in a freshly mixed concrete. The following properties are related to the freshly mixed concrete. First one is a workability. Workability may be defined as the ease with which concrete can be mixed, transported, and placed in position in homogeneous state. A good quality of concrete must possess good workability. Second is a segregation. Segregation may be defined as a breaking the cohesion in a mass of concrete. In a freshly mixed concrete, the large size aggregates sometimes get separated from the cement mortar during transportation due to bad handling. A good quality concrete should be free from segregation. Third is a bleeding. Bleeding may be defined as a separation of water or water, sand, cement from a freshly mixed concrete. Bleeding is generally caused due to excess water in the concrete. A good quality of concrete should also be free from bleeding. Now let's discuss regarding the properties of concrete in hardened state. The following properties are related to a fully hardened concrete. First one is the strength. Strength of a concrete may be defined as the resistance of a hardened concrete to rupture under different loadings, and may accordingly be designated in ways, that is tensile strength, compressive strength, flexural strength, bond strength, etc. A good quality concrete in hardened state must possess desired crushing strength for the structure. Compressive strength of concrete is most important. The estimate of tensile strength from the given compressive strength of a concrete may be made from the following formula. Flexural strength is equal to 0.7 under root Fc, that is in Newton per mm square, where the Fc is the characteristic compressive strength of a concrete. Second, durability. It may be defined as the period of time after which the concrete in hardened state withstand the weathering effects, chemical action, and whether wear satisfactorily. During the concrete during the durability of concrete directly dependent upon the quality of concrete. Water cement ratio also affects the durability of concrete considerably. The ensure better durability of reinforced cement concrete, the steel bars are also covered adequately. Then next one is the impermeability. The impermeability of a hardened concrete may be defined as the property to resist the entry of water in it. The concrete which does not permit the passage of water when subjected to water pressure is called impermeable concrete. A good concrete in hardened state must be impermeable to ensure water tightness of the structure. Next is the elasticity. The elasticity of a body may be defined as the property of the material to recover its original shape uh, after the removal of the load, you can say. A material does not possess an appreciable amount of elasticity. Modulus of elasticity of a concrete is primarily influenced by condition of elastic properties of aggregates and to a lesser extent by the condition of curing, age of concrete and mix proportion. Modulus of elasticity for compressive strength of a concrete, that is a structural concrete, may be estimated by the empirical formulae. Okay, so that we are going to study. Shrinkage. Concrete experiences shrinkage on hardening. Shrinkage of a concrete structural member depends on the constituents of concrete, size of member and atmospheric conditions. In similar atmospheric condition, the total shrinkage of concrete is mostly influenced by the water content in the concrete at the time of mixing and to a lesser extent by the cement content. The approximate value of a total shrinkage strain may be taken as a 0.0003. A good quality of concrete should experience the least shrinkage. Next one is the thermal expansion. The concrete expands as its temperature rises and contracts if the temperature lowers. The coefficient of thermal expansion depends on the type of cement, the aggregates, the cement content, the relative humidity, and the size of the section. A good concrete in hardened state should possess least coefficient of expansion. Temperature stresses in concrete structures may be avoided by providing expansion joints at suitable intervals. Creep. Creep can be defined as a continuous strain with time which the concrete structure undergoes due to application of the external loads. This phenomena is also sometimes known as time yield or plastic flow. A good concrete in hardened stage should be experience a minimum creep. Creep of the concrete depends on the various factors as a constituents of concrete, size of the member, stress in the concrete, age of loading, duration of the loading. The creep in a concrete remains proportional to the stress till the stress does not exist the one third of its characteristics of the compressive strength. The ratio of ultimate creep strain and the elastic strain is known as a creep coefficient. The creep coefficient under 7 days, 28 days, and 1 year are respectively 2.2, 1.6, and 1.1. Resistance to fire. A good concrete offers good resistance to fire. Next one is appearance. A good concrete on removal of formwork should have good appearance. Economy. A good concrete in hardened state possessing the above properties of characteristics should be economical for the given strength. Now let's discuss for grades of the concrete. Indian standard IS 456-2000 specifies various grades of concrete. So it expressed as a M, where M stands for the mix and X stands for the compressive strength of the concrete at after 28 days of curing. Now let's discuss this grades of the concrete, which are M5, M7.5, M10, M15, M20, M25, M30, M35. Now F5 stands the compressive strength as a Newton per mm square as a, so this particular number indicates the compressive strength in Newton per mm square. 5, 7.5, 10, 15, 20, 25, 30. Okay, so M5 stands the proportion 1 is to 5 is to 10, which is used for the mass concrete works for strong walls and foundation. M 7.7.5, it is 148 proportion for mass concrete for foundation. M10, 1 is to 3 is to 6, concrete like culvert and retaining walls, floorings. Okay, culvert stand for the small bridges. M15, 1 is to 2 is to 4 for a plain cement concrete. M20, 1 is to 1.5 is to 3 general RCC work as such as stairs, beams, columns, files, etc. 1 is to 1 is to 1 is to 2 M25 grade for retaining structures like dams, files, etc. Then M35 and 35, these are the design mixes which are used for the heavily loaded RC columns, RCC arches of a long span. Then M35, that is a pre-stressed concrete works, etc. Now let's discuss regarding the advantages and disadvantages of concrete. Advantages: cement concrete has nowadays been accepted as a useful construction material to construct almost every type of structure, including the foundation. The following are the advantages of concrete. The various ingredients required for manufacture of concrete are easily available everywhere. Freshly mixed concrete can be easily handled and molded into any desired shape. The concrete mix can be transported safely from place of mixing to the place of casting before its initial set takes place. Freshly mixed concrete can be easily pumped, sprayed, and filled into the cracks for repairing the existing structures and for lining the tunnels. Construction of all types of structures is made possible by reinforcing the concrete with steel bars. Monolithic character of concrete gives better rigidity and appearance to the finished structures. Concrete can be used for the various purposes, that is construction of walls, building roads, pavement, runways, water retaining structures, foundations, etc. in different climatic conditions. The property of concrete to possess high compressive strength makes a concrete structure more economical as compared to that of steel structure, and at the sometimes it is free from corrosive weathering effects. Concrete structures are quite durable and are not liable to decay. Concrete may be used as a soundproofing from uh, or for structures and not subjected to heavy loads. Concrete structures prove to be economical since their maintenance cost is practically nil. Now let's discuss some of the disadvantages also. Due to low tensile strength, concrete subjected to tensile stress is required to be reinforced to avoid the cracks. Expansion joints are required to be provided in a long structures if the temperature variance is more during the year. Concrete expands and contracts when with wetting and drying. Hence, contraction joints are required to be provided. Construction joints, you can say, to avoid the drying, shrinkage, and moisture expansion. Soluble salts present in the concrete experiences efflorescence if moisture reacts with them. Concrete structures are generally heavy in weight, and the structure loads develop creep in such structures. Concrete requires more time for curing to develop strength. Concrete structures therefore not suitable when the structures are required for immediate use. So friends, so this is regarding the plain cement concrete or the concrete properties in the freshly mixed concrete and hardened concrete. So in coming lectures now we are going to discuss regarding the various masonries and the properties of those. So thank you very much for joining the session.